Hi everyone, welcome to this technically exciting session on secure computer and hardware. Today's discussion will focus on how modern hardware, firmware, and secure architectures contribute or sometimes fail in protecting confidentiality and integrity, and what this practicality means for enterprises, governments, and technologies. So it's my privilege to introduce our moderator for today's session, Mr. Teja Chintalapati. Sir, I welcome you. Next, I would like to welcome our first panelist, Dr. Chester Ribeiro, Associate Professor, IIT Madras. Now we are joined by Mr. Rumit Shah, Founder and Director, GISA Softtech. Now I would like to welcome Dr. Suganya Annadurai, Scientist, GE SETS. And finally, we have Mr. Rajesh Kumar, Cybersecurity Consulting Partner, EVA India. A warm welcome, everybody.
Before we begin, I just ask Kamran. Kamran will split the share. Can I get all the gift cards? He was like, no, it's for the audience. Right. So please take your time to do the polls and the questions, and I hope I'll also be able to answer some of those and then get the prize myself. Right. So I think we have such an quite an interesting session today. I think I couldn't have asked for better panelists, right? We have um, in this specifically in this session, we are covering the entire gamut of security, right? I think I mean probably you know, probably you don't know all of them. Professor Chester works with IIT Madras, but more importantly, he's the foundation behind security of the entire Shakti processor, the initiative that IIT Madras has, right? So much interesting expertise, and not just research but actually applied research. He builds TPMs, works a lot on automotive security domain, and whatnot, right? So it's an very interesting the gamut that he's covered through his professional journey. And Rumit, dear friend, he's built GSASoft from the ground up. The entire HSMs, most likely, I always say that most likely OTPs from your phone, most likely maybe are coming from the system that he's developed, right? So Rumit comes with that actually commercialization of the deep tech background. And Suganya ma'am, she's with sets. Most of her work is not visible to all of us, including me. But whatever she does at sets is actually building the security of us as a country, right? So it's kind of quite impactful work that she and her colleagues do in Society of Electronics and Transaction Security in Chennai. And finally, Rajesh, right? So Rajesh is certainly a partner at EY, but most of everything that you do, unless it is in the market, right? And unless you tell the world effective story, unless you get the folks to understand the implications of security in devices and a lot of other factors, I think that's pointless, right? So this is a quite an interesting composition of panelists that we have. I'm very lucky to have all of them, and I hope I'll be able to make justice to their experience and expertise that they bring to the table. With that, a very warm welcome to all of you. And I want to start by asking a common question for all of you, right? So, the session title is Secure Compute and Edge Hardware, Confidentiality and Integrity in Hardware Path, right? What does it actually mean for security and privacy? I'm gonna ask this for all of you. So, when we say confidentiality and integrity in hardware path, right? That's quite complex. Even I couldn't understand what that means, right? Can we have a round of explanation from all of you? What does that actually mean in your context? So, Professor Chester, if I have to ask you, what does confidentiality and integrity in hardware path mean in the research context? What does that mean?
Yeah, Teja. So yeah, it's a very interesting title. Uh, so specifically, when you look at environments, right, these days, a lot actually comes up from the IoT space, and so you want to essentially have security right up from there, right? Because eventually your data originates from your IoT and then goes up to the cloud, right? So so one thing is it's not just your servers that need to be secure, but also your IoT devices that need to be secure as well. Now coming to specific devices and why security is essentially mandated or a requirement right up from hardware, I see two reasons, right? First is the aspect of as we've seen, especially in the last maybe 1.5 decades or 2 decades or so, there's a lot of threats which are actually coming up from the hardware. A lot is mainly because of the way semiconductors are actually evolved. It's more like a very heterogeneous kind of ecosystem now, right? So where you make use of third-party IPs and integrate it and fabricate it in some other third-party fab and so on. So chances are that your hardware itself is not secure, right? And due to this, you would need to kind of think of security right up from the hardware. So that is one aspect. The other orthogonal aspect is a lot of things which you actually try to do in software can be much more efficiently done in the hardware, right? So I'll just give you a very simple thing, right, which all of us know. It's with, I teach this in the class in my computer security class. The fact that you have these buffer overflows, and we've known this for almost like 40 or 50 years now. And you try to prevent buffer overflows on the stack, for instance, right? Or preventing exploits from the code injection on the stack and executing them. It's very difficult to handle that in software. But in hardware, all that is needed is one additional gate, one bit that essentially says that this particular page is non-executable, and then essentially prevents a whole lot of attacks. So what hardware can essentially do this way is that it can, with minimal change, it can actually prevent a lot of software-based attacks, right? So we are seeing a trend in both directions. So one is where you incorporate hardware changes such that your software ecosystem and your software stack becomes much more secure. And orthogonal to that is the aspect that you need your hardware itself to be secure and to ensure that what goes into your hardware is essentially trusted, especially with the diverse players in the hardware ecosystem, right? So yeah, this is what I think of from the title.
Okay, Rumit, if I have to ask you the same question, what does actually confidentiality and integrity in the hardware path mean in your context? What does that even mean?
To put it in simple words, if we wanted to put across, like confidentiality and integrity in hardware, it's like the data which when it hits the silicon, it should stay protected. No leakage, no bypass, nothing. It should be protected. That's what we feel like it should be in when it hits to the hardware. So that's how I feel across, and that's what we have to even when we talk further, we might also explore how we can take it further on those things.
Ma'am?
Yeah, good afternoon, everyone. So this is actually the interesting question. I would add one more thing along with Rumit. Yeah. So it's encrypting and verifying the data which is getting processed inside the hardware. So one example is when the hardware is performing its encryption operation. So one way is encrypting the data, and other way is how do we protect the key when it is getting processed inside the hardware. So that is also included in this confidentiality and integrity of hardware path. So when the data is inside the hardware path from the input to the output, and completely it should be encrypted and the confidentiality has to be maintained. And verification, if we comes, then how do we verify the integrity of the data? So that is one of the example that buffer overflow and any that we can verify the data when it is getting processed inside it. That is also comes under this. Thank you.
Rajesh, can you give us a non-technical understanding of this?
I was about to tell that part. I'm coming from a consulting background. So I'll set the context where we are hearing this, or probably a new shift in terms of organizations looking towards their OT security, looking at their edge devices, looking at telematics and everything. So if we take a step backwards, if we look at all these devices, these are legacy hardware. There were devices with very minimal footprint. You can't install any agents into these machines and everything. So we had a lot of challenges over that period. But if you see the last decade, or probably the last 4 or 5 years, there have been tremendous advances in terms of these devices. I don't want to bring any vendor name or everything. I want to be very vendor neutral. But I can take one product, for example, which all of us know. It's the Jetson Nano. Okay, so all these devices give that compute totally different dimensions. So there's a lot more that can be done in these devices. Not just act like a broker, take the data and send it to the data center for further processing, but they themselves can do a lot of advanced analytics, analytical and everything. Now the other advances that we are seeing that happening is that one of them is the HSM coming to the edge devices. In fact, I had a discussion with him just before the meeting, everything. So that is one of the things which we are seeing. The other part is also the quantum. So we have now the post-quantum. We will talk about that specifically when we talk about tampering, device protection and everything. So that is one of the things what we are seeing as a new change that is happening here. But no topic without, no session gets done without talking about AI. So today we have edge AI. We have LLMs which are defined or generated just for these edge devices, tiny LLMs, couple of other things and everything. So what has happened is not only the processing part, or not the advanced analytical capabilities part, even the decision making can be done at the edge layer. So that brings a big dimension in the way we look at these edge devices and everything. With that being said, there's a lot of changes happening there. So now I think we need to relook at the way we have been looking at these devices, especially what data is getting stored there, what if somebody can get access to this data, especially the privacy concerns, if data sent from one geography to other geography, everything. So definitely we need to relook into all these areas, considering the new changes that has been happening.
Okay, interesting. I mean, I know of several vendors, right? The silicon providers who are actually saying that our devices are different because we have an ML acceleration on the edge, right? There are a lot of microcontrollers I see from 2-3 vendors that I saw are actually differentiating their product offering with the AI capabilities at the edge. Yeah, quite interesting. And I think hopefully the PQC thing also comes in the next 2-3 years, right? Now that AI is there. So. Ma'am, I want to come to you, right? You have an interesting perspective on whole of this. We need to encrypt the data that's going in and coming out, right? I mean, it sets from what we understand, you've been engaged in actually building a lot of these IPs that go into the chipsets and also doing a lot of validation of everything that's going on, right? So if you actually have to look at the entire process from RTL to synthesis to silicon, right? Where do you think is the biggest where the confidentiality and integrity are getting lost in the entire design cycle?
Yeah. So when we consider from the conceptualization or the requirement to the silicon.
Yes,
right?
yes. From the requirement stage, RTL, synthesis and silicon.
Yeah.
Where is that area? Where is that?
I would say RTL to synthesis boundary.
Okay.
Yeah, because that occupy there the confidentiality and integrity is mostly lost, because when we are doing RTL, we used to take care of the attacks, right? For example, I'm fixing some countermeasures for side channel attack, or I'm fixing countermeasures for buffer overflow, or I'm fixing countermeasures for some security parameters. I used to take care of everything. So I will not be knowing after synthesis what happens to my timing constraints and
Right.
what happens to my power constraints, right? So I may make the power constant or time constant and all. So when we are performing the synthesis operation, so from RTL to the net list, when it transfers, I am not sure whether it is, unless or until we are very much aware of the constraints where to put. So that is the most part I would say. And I also have some examples. If we have a, okay, so formally verified information flow policy, so definitely it will no longer holds after synthesis because it will add some mugs. So it will add some vulnerability to that. And also the constant timing will get the data dependent
Yeah.
changes.
Yeah.
So there it actually gets lost. And second, if you want to say the second, then that's the synthesis to silicon.
Okay.
There the supply chain vulnerability
Yes.
will definitely come.
Yes.
Right, so that plays the second, but this is intended or unintended. RTL to synthesis takes the first place. So there we have to actually very much aware how to fix the constraints, so that we will not be losing the security properties which we actually wanted to do it in RTL.
Yeah. Okay.
Yes.
Interesting. I think we'll come to the whole supply chain side of it slightly later in the discussion. I think it's a can of worms that I don't want to get into because it's going to be a 2-hour discussion, right? So
Exactly.
so next question for me is Dr. Chester. So sir, I mean, ma'am rightly talked about design, right, and design stages and what goes into that. You also rightfully mentioned that essentially all of this hardware vulnerabilities and the process of thinking about security in the hardware level actually starts at the design phase, right? So let's say if someone have to implement, let's say, countermeasures, let's say power and DPA countermeasures or whatever, right? So there's certainly a trade-off between the cost, the area, and this one, right? Power consumption and whole host of other factors, right? So do you see actually engineers making right calls as they design the secure, fault-tolerant cores to have enough countermeasures while having essentially the cost versus the footprint and everything attached?
Yeah, I think it's going to be very application specific. Yeah, because yeah, it could vary, right? Like for example, if you're building a HSM and you better take care of security right up from the design phase, you wouldn't mind trading off aspects such as area and performance for something like a HSM, right? Because I mean that's what your device is essentially meant for, to actually create or manage keys and so on. But if on the other hand, right, so if you are looking at something totally orthogonal, totally different, right, like let's say some consumer electronics. So at this particular point, you may not want as much security as you would, as maybe compared to a HSM, right?
Yeah.
So this is a very tricky thing for a designer, especially now, because what we see happening globally is that countries are now mandating certification for various types of devices.
Right.
Right. So now I am developing, say, let's say a child's toy, right? And it needs to be secure, as we know. There's a lot of things on that. How much can I essentially trade off for security? Right. So this is an open question. I could possibly add more security features, and then, but it would also have an impact on my cost. And as we know that consumer electronics is pretty competitive, right? So even a few rupees or
Few
dollars,
cents.
yeah, few cents difference could actually make like quite a bit from an organization perspective. So yeah, so what is the way forward for this? I think, and also continuing with what Suganya mentioned, something that we essentially lack are security evaluation tools, right? So I think what we need are tools which would help designers to make these security decisions very early, right? So as of now, let's say you mentioned the power analysis,
Yeah.
the DPA thing, right? So if a designer wants to put a DPA countermeasure, he has to wait completely through to fabrication, maybe months or even years before he can validate it. There's actually no assurance whether the amount of countermeasure added is actually sufficient or not,
Yeah.
right? It's
Chicken
just
and egg problem.
exactly right.
Yeah.
So what we need to invest in is are on tools, which, for instance, like uh, tools that can not just optimize for power and area and timing and so on, but also consider security. So I could actually make a design. I could say that this is my security requirements, and along with, say, time and power requirements and so on. And the tool should be essentially compile or synthesize your design for that particular requirements. Right? So this, I think, is missing, and something we should be looking forward to.
Okay. Okay. Interesting. Now, actually, I will go back to Rumit, right? So now, let's say you have all the good security, you have a best product possible, right? But then of the day, you have to fabricate it, right? So, what are any structural problems that you see in India, right? Then when to or where is it not just Indian specific, but let's say globally? Is there anything that you feel should have been better so that there's a quicker time to market? Is it regulation is an issue? Is it availability of parts? Is it trusted partners, trusted supply chain? What are some of the issues that you see, Rumit, when you are bringing the product into the market? What are some of the barriers, and what is that one thing that we should do as a country to change, to essentially break those barriers, if I have to ask you?
So if we start with this and keeping in context with our experience and those things, so like firstly, we as a country, we lack into a secure chip with ourselves building here locally. Okay, so we don't have that chip part done locally kind of thing. So that's we have to depend on foreign players to do it. When we build across HSM, there are anti-tempering or anti-tempering temper resistant components which has to be done. Again, we have to depend on foreign. We have to, of course, definitely build this thing, but we have to depend on foreign players to give across this activities on this. So those are areas around that we, and of course in the crypto processing part also, we still have to either we have to go ahead and do that kind of design work, okay, and which is for a single company it's difficult, or we might have to go for a who have already designed and buy those licenses. Okay, so I mean that depends on us, like how we have to take it across, or how is the faster market, because if we design an HSM, there are a lot of components involved in that.
Yeah.
Each part requires its own life cycle.
Yeah.
And then once we design the HSM, it has to go for a certification. So if we go for an NIST certification, which is accepted here in India, FIPS, which is there, it would take. We don't have a lab in India, so again that's the second region. So apart from silicon and those things, the second is about the labs, which we don't have in India, like US or India market, we have FIPS which is accepted. European market accepts common criteria. And for a payment industry, we require a PCI certificate. So those are all labs which are not available in India.
But is there enough market in India to establish these labs, if I have to ask you?
So of course, definitely there is a market in India to establish these labs, which sir knows very well. I mean, there are a lot of things, and in fact, why can't we have these labs, and why can't we have all Indian certified devices accepted over there in India at least? I mean, right? If it has been certified for this particular product in India, why can't the acceptably be there for an customers who are buying within India for an Indian ecosystem, right? So that's the third point where borrowers don't even if we face this issue, even if our device would be certified, they would ask for maybe say you get across an European certificate also over there. So that brings across us that what we need to push across in market. So that's the third layer, that they should also be ready to, and they should be clear that what they want to buy and what is they are buying for, and whether there is a guidelines and those things which has been met across. So if they are clear on this, that's there. decision making powers has to be there with them, and there should be will to to get across this. And what finally as India need to do it is what I feel like is like we should have our own aggregated certifying authorities which certifies, or labs which can certify here in India. Of course, for Indian products, there should be discounted things, and of course, as we see labs outside India which are there, there are people from us we going and certifying our products over there, right? So we get and certify that. The people can also come here, right? So they can get it here if we have faster. I mean, if the labs are such, there are we have seen labs. There are labs in Italy or other areas. They are able to certify faster. So if you are able to bring that faster lab process within country, we will be getting more business here in India for the labs. So that's the area we should work on maybe, and get our products. I mean, if the Indian products are there, it can be consumed easily in India. Then
Okay.
that's my opinion on this.
Okay. What, Mubin? You are topping the chart here. Okay. So, so Rajesh, I think I want to come to you, right? I think you have quite a interesting set of experience in red teaming and automotive security and everything, right? So when you are actually assessing security of these devices, right, is there any pattern that you see, specific pattern where devices are getting failed? Is it secure boot? Is it something else? Is it any implementation? Is it buffer overflow? What is that pattern that you usually see that devices are failing as in more red teaming assessments are happening for IoT devices?
So again, I'll give a consulting answer to this one. Okay. So let me point at a couple of areas. So
Yeah.
for example, one, security through obscurity. This has been an old age
Yes.
problem. Now we had all the hard work that has been put by the scientists. We had all the hard work that has been put up by the OEMs and everything. But when it comes to the end user, the device doesn't get plugged just like that. There's a lot of customization that happens. They also take a conscious call on what I should have in my organization or function, or which features I need, do not need, and everything. Now again, let me split this itself into two layers. One is the hardware layer, one is the software layer. It will be very interesting to see how we got access to some of the devices. Again, no customer's name and everything. Organizations today think if you conceal the interface, the USB port or whatever the other devices, it's secure. So one of the first things when we do all this type of edge device testing, IoT, telematics, and everything, is pure hardware level hacking. So for example, how do we get interface to the computer? So for example, can I get interface to the device, pull out the firmware from it? Once you pull out the firmware from it, then pretty much most of the job is done.
Yeah.
Okay, so that's one area. The other area where we are seeing again it's failing is closely on the same lines on the how it gets disabled from the software side. Even if we get access to the software, the firmware and everything, what we do is we go look at the functionalities that we are seeing upfront and what are additional functionalities that are being offered by this one. Some of it can be disabled by the organization because they didn't want to have that one. Or some additional features are there because there's still an experimental feature which probably the OEM has pushed to the organization. So these are additional avenues of attack that any attacker can leverage. Now this is on the security through obscurity. Now the second part is the supply chain itself. So now we talked about the OEM. Now there's an organization which wants to leverage it, but the organization doesn't have the what you call the power or the support to do the customization. So they employ another organization like a software firm or a firmware development firm to get this work done for them. And what we have done is in this entire cycle, somewhere the firmware gets a leak. And for OEMs, especially from this particular space, like edge devices, IoT, telematics, and everything, the firmware becomes very critical for them because they operate in a different zone. Their commands are different and everything. So for example, if I have to send a command to a telematics device that you slow down the car and everything, between the various telematics that I've done, the protocols are different from one manufacturer to other manufacturer. Now, once I get access to this firmware, then I make a easy inroads into the
Yeah.
part. So that's the second part. Now, the third part is, while we are all looking at device, we looked at about labs, the need for OEMs and everything. The second part is how we look at the governance of these devices.
Yeah.
That becomes a very, very important part.
Hmm.
Now, we have the edge device sitting on a network. Now, what is this network? This is a network like an OT, like a telematics network and everything, which was never under the control or purview of the CISO or the security teams. Because they always, it's this old myth which they say, my network is segregated, nobody can access my network. This is still going on, but there are mature organizations as well. I have to say that there are mature organizations who have put adequate controls as well, but that is still picking up. We expect most of these organizations to take that first step, because no matter how much you secure these devices, if I can find one entry into the network and get a foothold into the network, then for me, targeting this other devices becomes much easier for me. So that's the other part of it.
Okay. Oh, okay. I know we have an interesting discussion ahead, so but we are short on time. So I'll want you to, if possible, limit your answers to maybe less than a minute, ma'am. I'll come to you. It's going to be a difficult one to keeping it under a minute, right? But ma'am, if I have to ask you, right, you mentioned about supply chain. Right? This is a can of worms. It will go for 2 hour, 3 hour discussion. But let's say, as a country, we are, or even as a solution provider, right? You are dependent on a lot of third-party players. I mean, we did an analysis. Someone did an analysis wherein for a chip to come out, you need to work with 5,000 ecosystem players, right? From fabs, each fab working with hundreds of subcontractors and whatnot, right? Supply chain mein there's a any entry point into the entire chipset fabrication thing will actually impact the entire security posture of a chip, right? So if someone comes to you and asks you, okay, ma'am, can you tell us what tests that we need to perform to ensure that my IP, my hardware is actually secure enough and not vulnerability, right? Not have any backdoors and trojans and whatnot. Is there anything like that exists in the whole world? No.
Okay, the answer is no.
Okay.
Okay, but we can build a portfolio of evidence, right?
Right.
So we can build a portfolio of verifying the implementation, verifying its authenticity of the IP, or verifying its origin, or its implementer, or even the supply chain. And also we can have different, we can create different evidences. Okay, my crypto algorithm is, or my device is secure. So one is, there are certifications, as I said, there is a FIPS 140-3, and now it is ISO 19790. So actually India is developing a reference lab, ISO 19790, and hopefully it will be there, CDAC Bangalore, and we are doing ISO 17825, that is for side channel, and Dr. Chester is also contributing to both of the labs. Yeah, a lot of efforts are going on. So hopefully we will be having a lab in a year. So STQC will be the certification body, and they will be performing the test and evaluating it and doing it. So one is the certification process that we can go. And another one is, we can have a separate side channel test and fault test report we can generate. So that is one portfolio of secure implementation. And another is the supply chain. We can threat model, a recording of each and every evidence from the design state to the deployment state. So that each and everything will contribute to, okay, this device is secure. So that's the short answer I could give.
Okay, ma'am. Rumit, I'll come to you quickly, right? So I think Rajesh mentioned that AI is all on the craze right now, but I also see quantum is emerging as something that is going to come up very immediate future, right? So one of the things that we talk in quantum is actually agility, right? So agility, we mentioned crypto agility, ability to change algorithms, but at the end of the day, you need to also have a hardware that is agile, right? Because if your algorithms, PQC algorithms, because of the whatever the amount of memory that is required, throughput and whatnot, if the hardware itself is not agile, it's going to be a very costly transition, right? So from your advice, what is that advice that you are giving to these companies that are planning to buy, let's say, HSMs, so that they can be hardware agile in the terms of PQC migration?
Uh, I'll not restrict only to HSMs, maybe any hardware which we wanted to take. so, when now when the techniques are coming across for QRNG, PQC, again still evolving. I mean, it's not. I mean, we got 3 algorithms which is there, but we might have our own algorithm. We don't know. So it's still evolving, and we might have something which can be for the next 5 years. If we see a hardware right now, in next 5 years it might get absolute for us. I mean, we will not be able to use those hardwares because things might change by that time, and we would be into quantum world maybe, or threats would be there which can give those kind of issues. So the advice is that we should take in hardware which are I mean, where we can do a field upgrades. Okay, the firmware upgrades can happen, upgradable things. It should not be that way that the hardwares are such a way that they're not upgradable. They're not capable of handling this thing. That's the advice. We should be able to do a pluggable algorithms on that. Instead of just doing firmware upgrade, we can plug some algorithms where we have designed something which is similar to that, where we can do a pluggable hardware or keep a core where we can run a pluggable algorithms, pluggable our own custom codes we can run across. So that kind of be an hardware design should be that way, or we should take across engage with hardware vendors who have their vision for 5 to 7 years, which is there, which should have this kind of play areas which they are working on, so that the design or the hardware which you take across right now in the market can work across for next 10 years or something like this, more than that kind of thing. So your devices, because normally when we see edge devices, they're not the life is more, I mean, it's beyond 10 years and above. The life is that way. So we should have devices in that line. So if we are taking a hardware which are field upgradable, we can have algorithms which can be inserted over there on this, and attestation possibilities are there. Then those are the advice which we can take across to buy those hardwares.
Okay, awesome. Okay, sir, coming to you very quickly, if I have to ask you, right? I mean, when usually enterprises or as individuals we buy a processors, right? Security or buy a processor to build your system on. I think nowadays it's evolving, but usually people go for performance as a benchmark, right? Okay, what is the performance that we are getting out of it? What is throughput and whatnot? Security is always an afterthought, right? So do you see this approach changing, and wherein essentially people are preferring to have a better processor in not just specified context like HSM, but maybe all the contexts? And how do you actually see Shakti playing a role in all of this?
Yeah, again, I don't think security is going to be the main stage, right? So, in fact, like if you ask one of the big players, Intel or Qualcomm or things like that, right, whether they would want to add a feature for security or performance, they'd probably choose performance over security. Yeah, and a lot is actually going to be there. Now, for a lot is driven by the customer and the users market. So you would probably go buy a mobile phone not because it's secure, but it's got a special feature, right? And as we have seen, this thought from a user actually goes into back into the OEMs and then back to the processor manufacturers and things like that. We are actually seeing some very nice evidence of these things playing along. Now, therefore, security is going to be there, but users would actually expect security by default rather than buy for security, right? Unless they are looking for security critical applications, HSMs or authenticators or things like that. And in such a case, security would be the top priority. Now, this being said, where do we see the Indian perspective? I think, Romit, actually you mentioned about the security processor. So that's something actually again being developed in India. So I do work with, at IIT Madras, we are also looking at extending security, Shakti with security. So we've got features which now I think stands out globally and has been accepted. What we are now looking at is to kind of as of now being tested on FPGA, but then want to essentially see how we can commercialize it, right? So that being said, I think I would give a target of say 2 years down the line, India would have their own secure element, right? So with the tamper resistance and things that you are talking about.
How can he build on top of that?
Yeah, yeah.
Okay, interesting, sir. Rajesh, coming to you. Let's say this is, I couldn't find the better person to ask this question to you rather than you, right? So, if as India we have to pick one domain, let's say automotive, telecom, fintech, secure silicon, IoT for global leadership in secure hardware, right? Where do you think we have the strongest shot?
So rather than to say where do we have it, where do we want to have it, I will just change that part. I would prefer the SIM, the semiconductor part. There's been a lot of push by the government as well. Government
Yeah.
is backing, you understand, the India semiconductor mission
Yeah,
as well.
yeah.
So that is one. So there's a lot of financial support that organizations are having it.
Hmm.
We're already seeing the first movement. I think Dollar is with one of the plans that's just coming up and everything. We are always already seeing no hardware players here. And apart from this, I'm seeing a lot of this new age silicon or the chip manufacturers being coming up. And there are companies who are looking at this space of know how to invest because we are in that space. We work with them, some of them, and everything.
Yeah.
So my bet would be on the semiconductor part.
Yeah. Okay. All right. So I think with that, in the interest of time, we'll have to close the questions. But it's quite an interesting, I think, good 15, 20 questions. But one question that have won the majority of votes is quite interesting, actually. Mr. K.N. Singh is asking all of us, how do you actually perform hardening of any hardware with any applications with visibility of component inside hardware and their purpose? Is there any way that we can find there's a malicious component in the hardware? I think he's referring to the attack that happened in the Middle East, right? So is there any way that we can find out what's happening in the hardware level?
Yeah, I think I can answer that. Yeah, I think this is people have actually woken up, at least researchers, academicians, industry have actually woken up to the threat that attacks can actually originate from the hardware.
Yeah.
Right? And recently, there's also these CVEs or the CWEs, which now have hardware also, which are actually dedicated for hardware as well. So what essentially it means is that you can now look at CWEs in the hardware. Similarly, there are tools, there are actually global contests which are conducted annually, right, to actually develop and actually find these. So unlike software, the hardware perspective is not that developed as yet, right? And things are actually evolving.
Yeah.
Right. So for example, there's this famous contest called Hack at DAC and Hack at Chess and things like that, where actually these vulnerabilities are introduced in the hardware and teams are actually made to essentially find these issues. At the same time, just like we have tools for software, similar tools are actually being developed for hardware as well. Right? Fuzzing, for instance, has been used quite a bit in the software in the past. Now fuzzers have been adopted for hardware. Right? Things are not as efficient as mainly because it's not been researched as much as the software, but these things are actually evolving, right? And I see like these tools catching up in the future. So chip manufacturers or SOC manufacturers would essentially security validate their chip and not just functionally validate it, right, before essentially deploying.
Okay, all right. This one last question, Mr. Ankit Berry. He's asking what steps are required to develop the fab labs in India for hardware development. I think we have enough design talent here, but I'm not sure how much of them are relevant for security. How can MSME sector play a role in this? Rajesh, maybe you want to take this? So essentially, I mean, I can take that question myself, right? So essentially, I think in terms of fabs, I think there's enough momentum right now, maybe at least 3-4 labs, right? But India is always known as a design powerhouse for semiconductors, right? But lately, from DSA's perspective, we are seeing key security work is gradually coming into the country. I mean, still a lot of hardware security is still mostly US driven by a lot of, for example, from TI to Silicon Labs, and most of those folks have a design security design teams based out of US. But we certainly see a lot of that momentum being carried forward to India, right? Essentially, not just as for the functional security, but also actually core security. We're seeing a lot of teams that are getting built in the country, and then I think the Professor Chester's work and a lot of ecosystem that we are seeing out of Kharagpur and Madras and Kanpur is driving a lot of that. So with that, we come to the end of the discussion. All of us are here for today and tomorrow, if possible. Do try to network with us. We would love to take your questions and then look forward for the discussions. Right? Thank you so much for all of you, and we look forward to having the discussions with you.
In the session, and thank you all the panelists for an insightful discussion. Now I would like to present you with the memento as a token of gratitude.